Hello, welcome. Today I try to solve Leetcode problem 78, subsets. So we are giving an integer array nums, and inside the nums, we're gonna return all possible subsets of the power set. So what we're gonna do, we just find all the subsets, as you can see for 1, 2, 3, so there are 8 subsets. Let me first explain the problem in the whiteboard and then go back to the code editor to finish the coding. So for such problem, I'm going to use 1, 2, 3 as an example. So in this example, we're going to use the backtracking to solve the problem. So from the beginning, I just make a drawing of O. It means nothing. Yeah. So for the first step, we're gonna choose the first. We're gonna choose the first number. What are we gonna do? We're gonna go to the first index. So we have two conditions. We can select and not select. Yeah. So we can select this number and we have two conditions. It depended on which one we're gonna choose. So we're gonna, if not select, we're gonna get an empty array, and if select, we're gonna get 1. And then we go to the second index. We're gonna decide 2. So for this 2, we will not select, it's empty. So if we select, it's 2. And similarly for all others, you can see for this one, we select, we not select, and select. After all, we got all the combinations. As you can see, there are 8 combinations, and that is the result. We just need to put this inside the result. As you can see, this is a typical select and not select backtracking pattern problem. Let me first finish it into the code editor and then try to summarize some of the similar problems. So for this kind of a problem, it is basically select and not select backtracking problem. So we can prepare a result. So this is for the final return, and n as the length of the nums. Now we can define the backtrack function. So inside the backtrack, I'm gonna first prepare an index because I'm gonna check all the indexes from 0 to n-1. And then I'm gonna prepare a subset. So this subset means while I find a result subset, I'm gonna put it inside the result. So first of all, I'm gonna check the conditions to stop the backtracking. So if I equal to n, it means I need to take the subset into my result. So I need to result dot append the subset. And then I need a return because I want to this DFS, this backtrack to stop and go for the next one. So this is why I need a return just to speed up a little bit. And now I can use the backtrack. So first of all, I can decide for the next index, for the next number, I can decide. I have two conditions. One is I need to select and another is not select. So first of all, I will select. So the subset should plus nums I. This means I gonna select. Another condition is while I go to the next number, I gonna not select. So not select. So this is not select. So finally, I just need to return the result. But before return the result, I need to call the backtrack function. So inside, I'm gonna start from index 0, and the subset will be an empty array. Now let me run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases. Now let's analyze a little bit about the time complexity. So the nums length is maximum 10. So actually the combination is about all the numbers. So the time complexity is 2 to the power of n. N is 10. And while we are, as we can see also from the drawing, so this is the final result. And the space complexity, it is log n. It depended, on the n is 10, so log n is also a very small number. Yeah, but inside, let me go back. Yeah, but inside we also use the sum space. Yeah, so inside I'm gonna also use the subset as my actual space. So it is a 2 to the power of n, but for this n it's not a big number, so it is okay. Yeah, now let me summarize a little bit about this kind of a backtracking problem. So I call this problem as the backtracking. You can check you can check the Leetcode and go inside to check the similar problems. Yeah, so basically for the backtracking problem, we're gonna do the terminations. So this means how we can get the result. So this is the termination. And the second step, we're gonna do the tracking. So this is basically DFS. And sometimes we're gonna need trimming or not trimming. It depended on the requirement of the problem. If the value if the n is a very big number, maybe we need to do some trimming. Sometimes we don't need. Yeah, and for this pattern, I'm gonna call it select or not select pattern. And as you can see, there are some similar problems for this kind of a pattern, select or not select. Basically, it's totally the same. As you can see, this is a subset, and there are also others, like the binary tree path or the smallest string starting from leaf or path sum 2. They are basically the same, and binary tree path. This problem basically the same, and sum of all subset x on totals. Yeah, it's similar to the subset, and generate parentheses. This is a little bit different. Yeah, this may be the hardest one, but basically it's the select or not select problem, or select left or select right problem. As you can see for this problem, you can just try to check the code from here. Thank you for watching. See you next